triangles that you'll see. They may look a little bit goofy, but let's turn that to our advantage. Okay, as I said, ratios must always go from least to greatest. So we have the 3, 4, 5 right triangle. I keep repeating right triangles so that you know this only works for right triangles if we're sure it's a right triangle. If it might be a right triangle but it might not be, we can't use it. We have to assume, you know, worst case scenario. So the isosceles right triangle, just using kid talk, is a 45, 45, 90 triangle. And notice that's least, tied for least, greatest. And those have a ratio in the sides of 1 to 1 to square root of 2. Okay, that can look goofy, or it might even look intimidating to some. Let's turn that to our advantage, because when you see that in the answer choices, they will stand out by its very weirdness. Okay, so again, this is imaginary, understood, 1 times 1, 1 times 1, 1 times square root of 2. So if I tell you I have an isosceles right triangle that has sides of 3, 3, and x, again, isosceles right triangle, what is the value of x? Outstanding. No, no. The groovy thing here is that you don't have to mess with square root of 2. The answer is the same multiple 3 times the square root of 2. Square root of 2 is already the most precise way to define what square root of 2 is. In that way, think of it as being like pi, where any other, 3.14 whatever, is going to be an approximation. And the only precise way to tell us what pi is, its recursive logic, is to tell us that it's pi. Okay? The only precise way to tell us what the square root of 2 is to say square root of 2. So the good news for you is you don't have to get involved with a number like that. Just leave it alone as square root of 2. Don't try to go under the 10th there of the square root and deal with it and come up with 6 or 9 or anything else. Your answer is as awkward and clunky looking as 3 times the square root of 2. But there's the beauty of it. Okay, when you're going through the test, if you look at the possible answer choices, and they're 3, 5, 7, 4 times the square root of 2, you're going to say, wait a minute. I'm walking down the street, minding my own business, and I got 3, 5, 7, and all of a sudden I got 4 times the square root of 2. Why would they give me an answer 4 times the square root of 2 when I'm dealing with a right triangle here with the side? Oh, okay. The answer choices themselves can be your best friends. Okay? If something stands out as very different from the pack, sometimes it's wrong because it's so far astray that it's just goofing on loco weed. But other times, that's the only answer that can be right because it's the only answer that contains a certain element that's necessary, divided by 2 or to the second power, or, whatever. And so that's how we're going to turn this to our advantage. Rather than being nervous about working with square root of 2, we don't care because square root of 2 could just as well be x or y. And nobody's asking us to solve it out any further. Now, just for your own curiosity, because everybody's going to want to know, square root of 2 is approximately 1.4. But you'll never need to know that. They're never going to ask you to give a number approximation of what square root of 2 is. Square root of 2 is itself the perfect answer. And so in this case, 3 times the square root of 2 is the answer. I mean, you're not being evasive. You're not failing to simplify or solve it out. That's the most precise way you could say it. Anything else would be an approximation, but it would also be going to too much work. 3 times square root of 2 is all you got to do. You don't got to say it any further. So let's just do one more. I mean, if you had another isosceles right triangle with sides of 7, 7, and x, what's x? Yep. Yeah. Okay, yes, it's 7 times the square root of 2. I mean, everybody got that point. One of you wanted to take the approximation, but first of all, you can't do that, and second of all, you don't want to do that because that's unnecessary work. But second of all, it wouldn't be quite accurate. It wouldn't be quite exact. And they'll never give you a question in that format where you have to take 1.41 times a number to calculate what it is. It's in terms of square root of 2. And so the answer is 7 times the square root of 2. And you look at that as just you're applying the same multiplier across all 3 numbers. Okay, in the base case, it was 1 times 1, the same 1 times 1, and the same 1 times 2. Then that was consistent. That ratio was equal to, if you made the multiplier 7, then you had 7 to 7 to 7 square root of 2. Those 2 ratios are equal to each other. You just have to be sure that you multiply by the same multiplier for each of the numbers. Just as importantly, though, these angle measurements never change. Whether you make that pyramid, imagine like taking your fingers, your hands, in the shape of a pyramid and pull them apart, push them together, pull them apart. You may get a bigger or a smaller pyramid, but the angle measurement never changed, and the proportion of the sides from one relative to the other never changed. So think of, you've got a little keychain of a pyramid. You look at one side, okay, and it's isosceles. And its sides are 1 centimeter to 1 centimeter to, square root of 2 centimeters. So that's approximately 1.41 centimeters. And so on. Now, let's say, in the corporate meeting room, you had some futuristic monstrosity centerpiece at the table. That might be 1 meter by 1 meter by square root of 2 meters. The angles never even thought of changing, and the sides are still in the same proportion to each other, even though in absolute terms, this thing just got 100 times longer per side. And finally, let's just assume the real pyramid might be 1 kilometer by 1 kilometer by square root of 2 kilometers in size, which again, okay, if we put this in terms we're most comfortable with, like 1.41 kilometers by 1 kilometer by 1 kilometer. But the angle measurements remained exactly the same, and the proportion of sides never changed. So that's how to learn to love the isosceles right triangle and its funky square root of 2 answer choice. We've turned bad news into good news, because if you see that, you see something weird in the answer choices, it's there for a reason. It's never just purely at random. So if they give you 23 and